Hello, I'm Jocelyn and I'm a physicist. And what drew me to physics in the first place is the fact that physics is crazy. Physics is like sci-fi, but with math. And the really cool thing about physics being like sci-fi or even fantasy is that a lot of times sci-fi and fantasy have a lot of real physics in it. And we can actually learn a lot about our world and real world physics by thinking about how sci-fi and fantasy are different and what aspects they've taken from real science. And so this is my show, Fiction, where I will look at some of the things that go on in sci-fi and fantasy and how those can relate to real world physics, or even just how real world physics can seem like fiction. That is the origin of our name. And so for this, the very first episode of Fiction, I'm going to delve into something very close to my heart. Two things, in fact: Dungeons and Dragons and light. So without further ado, let's start talking about light and vision in Dungeons and Dragons in this episode of Fiction. You can't talk about light and vision without starting with the way that we see the world. Our eyes. Because the eyes are really impressive. Like, the fact that these evolved at all is really neat. An eye works the same way as basically any light detector. You have a few key components. You have the lens, which collects light from all over and focuses it down into a smaller region. And that region is a detector. This is called the retina, and that's at the very back of your eye. The retina is made up of smaller individual things called rods and cones. And those are the things that are actually detecting the light coming into your eye and sending the signals to your brain. The interesting thing, though, is what differs between rods and cones. Rods are just kind of on-off switches. They just go, is there light, is there not? What this means is that they don't really help with color. They're mostly just there to say something is there. What people have a lot of are cones. And cones are what actually let us see color. Because cones actually see some colors less. And this is where you get the issue of vision. If you've got a detector that's just saying on or off, then if you want to tell the difference between a whole bunch of things, you gotta be off for a lot more of them. So cones actually come in a couple flavors that are centered on different parts of the what's called visible spectrum. These are all the different wavelengths or frequencies of light that people can see. If you look at it on the electromagnetic spectrum, visible light is this little tiny region. Although we'll get more into why it's visible light is what it is a bit later, because that's also a very neat thing. The important thing is visible light has a bunch of different colors that we see around us. So the cones in our eyes see some of those colors really well. But that means that they've got to see the others worse, because you can't really see more than there is. That's kind of the issue. That means that cones don't get as much light. They kind of see worse, which is fine for people because we're mostly out in the day. And in the day, there is so much light around, it doesn't matter that we're ditching almost all of it because there is more where that came from. The problem is at night, and that's why people don't see great at night, because we don't have all that many rods and cones are pretty useless. That's also why you see mostly in black and white at night, because the cones aren't really functioning, so it's just rods basically saying, there be light. The interesting thing is then to tie that into something like Dungeons and Dragons, where you have a bunch of races in Dungeons and Dragons terms, that have dark vision. The cool thing is, the fact that dark vision describes usually people seeing at night in shades of gray, that's pretty accurate, because that would only happen if rods are functioning. The weird thing is, all the people with dark vision in D&D can see just as well during the day, and that's weird. Most of the time when you get nocturnal creatures in the real world here, something like a cat, although they don't have dark vision in Dungeons and Dragons, but that's a whole other thing. And I think that's been commented on enough. When you get something like a cat or a raccoon, they have more rods than we as people do because they've got to see more at night. So it matters a lot more to them to be able to see more light, because there's just not that much light at night, than it does for them to be able to see colors really well. The kind of side effect of this is that they don't see color as well. So a lot of cats are kind of colorblind. In fact, a lot of creatures that are out at night don't see colors as well because they just don't have as many cones. I guess in Dungeons and Dragons, we've somehow got the implication that creatures like elves have just as many cones as people, but way more rods. I mean, magic exists, so that could be a thing. But also, I think it'd be pretty cool for a lot of these races that are meant to be out more, maybe in dim light or at night, to actually be colorblind. Doesn't really change the game mechanically much, but it's kind of an interesting ode to real world physics of the fact that, you know, just in general, you're going to have a trade-off. You're not going to have as many cones as someone who's out during the day. If you're out at night, you're going to focus more on your rods so that you can see better. And that's just kind of an interesting aspect that you could add. The other cool thing to think about is a lot of times when we're talking about maybe like delving into a dungeon and you've got your torch out, you walk into a dark room and all of a sudden the torchlight gleams off the eyes of all the goblins in front of you. What is the eye gleam though? And why is it that we always imagine creatures like goblins having it, but not a creature like an elf? When you actually get down to it, eye gleam is a function of dark vision in a way. Creatures that have that eye gleam, like raccoons or cats, what is actually happening is that they've got a reflective coating inside their eyes. This is pretty cool, and it's a neat thing that they adapted, because at night you just want to get as much light as possible because there's just not enough to go around, and that's why it's hard to see. So the issue with your eye is that the lens is pretty good at focusing light in, but some of it's gonna not make it through. Some of it's going to not hit the retina, and if it doesn't hit the retina, well, you don't see anything. It doesn't help. So what some creatures that go out at night have is they actually have a reflective layer inside their eye that reflects back some of the light that would otherwise escape. So they get more light and can see better. But that reflective layer also reflects light that's coming in at weird angles that, wouldn't normally help. And that's why when you, throw up a light source all of a sudden, some of that light goes off the reflective layer and comes back as gleaming eyes. But this means that almost anything that has dark vision would in fact have a use for having a layer like this. So you could walk into a darkened council chamber full of, the very high mages of the realm, these elves, great 700-year-old elves, throw up a torch and have their eyes gleam back at you, which I think is pretty funny, to be honest. The last thing that's an interesting adaptation that a lot of creatures have with dark vision is big eyes. In fact, usually the thing with big eyes is that you just want to get more light, but it means that you tend to not see as well in the day because then you just get too much light and get saturated. That sounds a whole lot like a drow sunlight sensitivity. I really want drow to just have giant eyes, because that would be really funny and also kind of cool looking. I mean, why not? Why not have Dritz show up with eyes the size of his fist? I don't know. There's a lot of cool things you can throw into the game if you decide to take into account some more real-world physics. Although honestly, Dungeons and Dragons does a pretty good job of incorporating some real-world physics already, sometimes even possibly by accident, which might be the case for the next thing I want to talk about. And that is actual light sources. When you're playing, you need to usually have a light source when you're in the dark. I mean, yes, maybe everyone has dark vision and you're seeing okay, but even then, you can't see color. So at a certain point, you're gonna need some light. The common thing you do is just throw up a torch, because everyone has a ton of those that everyone usually forgets about. But another cool light source that maybe doesn't get as much love as it should is the candle. And the candle is what I want to talk about, because that actually has a lot to do with real-world physics, and I think this is pretty funny. The candle in 5th edition Dungeons & Dragons sheds dim light for 5 feet, and bright light for 5 feet and dim light for another 5 feet. But 5 feet in Dungeons & Dragons is essentially a unit. Like, that's a square. Which means that candle is kind of the unit of light. And what I think is really cool is that a candle is also the unit of light in the real world. That's actually how you have to measure luminosity. It's called a candela. And this is actually kind of an interesting thing to think about, because it's one of those things that seems very obvious. Like, I can describe how bright something is. Like, I see the sun and I see that that's really bright, and I can see a light and see that that's not as bright, but I can also see, one light being brighter than another. It seems really obvious. But when you actually try to define it, it becomes really hard. And that is for an interesting reason. You see, when you have light, a lot of times you would just, in physics, define stuff off of like power or energy. I am radiating this much power right now. I mean, you think about it, you got like a 5-watt light bulb. Well, that doesn't actually tell you how bright it's going to be at all. And that is because of the way we see. And this gets back to our eyes, because our eyes only see some light. Light technically covers the whole electromagnetic spectrum, but we only see a tiny part of it. And even more importantly, we only see some of it that well. If you look at the way that your eyes see, you see green so much brighter than you see red. That's why if you've ever looked at like a green laser pointer or a red laser pointer, the green one usually looks a lot brighter. And that's not because they're sticking a whole ton more power into that green laser. That's just because our eyes see green light better. And that is for a really, really cool reason that I want to get to a little bit later, because that's another fundamental thing that is just so cool. But the important thing is, we see different lights, different amounts. So in order to actually define how bright something is, you have to take the light that gets emitted from something, how much gets emitted at what colors, and then multiply that by how well we can see it, and then add all those little pieces up. And that's the only way to get how bright something will be based on how much power it gives off. But that's kind of a weird thing to measure. And so originally it was just measured based off of, this is how bright it is compared to a candle. And that's how we got the unit candelas. So it's actually kind of realistic in Dungeons and Dragons that a candle is the base unit, because that's just what physicists did. They went, well, people have candles, so let's just say, is it brighter than a candle? And it's kind of a funny thing that you ended up with this nowadays. Now that we know a lot more, we're still just like, okay, is it brighter than a candle? And that's kind of fun, because that's how a lot of physics has developed. I mean, the more you look into physics, the more you kind of have to ask yourself, how did this come from historically? And there's a lot of stuff that honestly is weirdly named when you think about what it actually is, but makes a lot of sense in a historical context. Physics is cool. Dungeons and Dragons. Because now we can actually get to talking about some stuff that is only Dungeons and Dragons, and that is magical light. And if I'm going to talk about magical light, I gotta start with the light spell. The light spell is this. Now, wizards, they're supposed to be kind of like the physicists of magic. I mean, that's the whole point. You're supposed to be so into how things work, and that's why there's all these rules to spells. So, let's be wizards. Looking at the light spell, it very specifically makes you touch an object, and then that object emits the light. This is actually kind of weird, because that means that you're not just summoning light, you are making an object emit light. And there's a few ways that happens. We can base this essentially off of light bulbs. Let's just consider, how do we make light bulbs? There's kind of three main ones you can have: incandescent, fluorescent, and LED. If it emits light like an incandescent light bulb, that would be interesting. Incandescent light bulbs use something called blackbody radiation. It's called blackbody radiation because it was developed by saying, okay, here is just a hot object, a body that is just, we don't necessarily see any light coming off of it. It is just a black box that has heat. What kind of light is that going to give off? Where light just means any sort of radiation on the electromagnetic spectrum. And what you get from that is a spectrum that varies just based on temperature. You can determine off of the temperature of anything, what is it going to be, the general radiation it gives off. For example, people give off something like this, where you're in kind of the infrared radiation section, not very much. We just give off some heat. That's how we interpret infrared radiation. The sun looks more like this. And here is where we get to that really cool thing I alluded to earlier, which is why the visible spectrum is where it is. If you look, the light given off by the sun, here is the area that is the most light it gives off, and that is the visible spectrum. We have the visible spectrum just because the temperature of the sun. That's what the sun gives off, so that's what we see because that's what there is. Which is cool, because that's all just based on the star and what temperature our star is. So technically, if there was a planet orbiting something like a red giant, which is a cooler star, they could see different colors than us. They might not even be able to see some of the colors we see because there would be no point, because they don't have that same brightness, because their star is cooler. I just think that's really cool. And I hope you do as well. So, if our light spell is causing something to emit blackbody radiation, we need it to be less like people and more like the sun. In fact, that's similar to what an incandescent light bulb gives off. An incandescent light bulb is cooler than the sun and a lot smaller. But because its temperature is close enough, we get light that looks pretty close to visible. In fact, it's a bit yellower. It looks a bit yellower to us because it's a bit cooler, which means it's shifted more to the red side of things. And that's why, incandescent light bulbs look kind of yellowish. So that means, though, that our object, we are heating up some point of it to this temperature. And that's hot. Incandescent light bulbs are really hot. So if you are, say, touching somebody's hat to make it glow, you have heated up some part of that hat to a ridiculous degree that is definitely going to cause some damage if it acted like blackbody radiation. So, light spell, probably not doing that. But that's also the only way to just have an object emit light. Anything else requires something a little bit trickier. Let's take fluorescent light bulbs now as another example. Fluorescence is a very cool effect. I've done a bunch of stuff with that as in physics, and it's one of my favorite things, because fluorescence is basically giving some light to something like a molecule. It takes that in, uses up some of the energy to kind of shuffle around a little bit, and then sends out light with less energy. There's a lot of cool stuff you can do with this. And one of those is fluorescent light bulbs. Essentially, fluorescent light bulbs have a gas, electricity comes in, excites the gas, and then the gas, uses some of it, shuffle around, and then emits the rest of it as light we can see. That's why they're a whole lot cooler, because you're not heating it up a whole ton. Fluorescence is a much cooler process, but it requires you to be giving in something like light or some kind of energy, and it only comes out at a very specific frequency based on the molecules you need to have. So if you were just taking a random object, you would need to be constantly giving it energy, which I guess, sure, maybe magic, but then you would also need to be sticking some molecule that emits the light you want it to in that object, which becomes not even the object really giving off light anymore, so it's probably not fluorescence. The last effect we could talk about is LEDs, but that's a whole other thing, and honestly, probably not that, because that's relies on the very specific properties of a very specific material, so that's something for another day. It seems, though, if we look at the spell, like they mean it to be some kind of sometimes a fluorescent thing, or possibly the very related aspects of either phosphorescence or chemiluminescence. Because if we look at the components you require for this spell, it is either a firefly or phosphorescent moss, both of which emit light in a similar process to fluorescence, but a little bit different. A firefly uses chemiluminescence, which is basically you have molecules, when they interact, they have a reaction, use up some of that energy in the reaction, and then emit other energy as light. That's how fireflies work. It could also be called bioluminescence, since it is in a living organism, but semantics. This seems like it might actually be the most feasible aspect so far. It means that in your light spell you are creating some molecules that can then react and emit light, but at least you're not burning anybody or requiring a constant flow of energy into the substance. You just need to make a bunch of molecules show up. It's also probably not phosphorescence, because the other component, which is phosphorescent moss, would work off of phosphorescence, but phosphorescence is basically just fluorescence. In fact, the line between fluorescence and phosphorescence is so narrow, it basically is down to what you choose to define it as, because phosphorescence is just fluorescence that takes really long. So, in the end, we probably don't know how the light spell works, because it doesn't really work anything like the physics we have. But the best bet is that you're basically making a bunch of molecules show up, they react with each other, and send off light for an hour. I mean, yeah, it's magic. That's close enough. At the very least, there's a lot of very cool stuff that can go on. And even in the real world, there's a lot of really cool stuff that can create light. In D&D, there's also a lot of cool stuff that can create light. That's getting into a whole other thing, though, if we're going to get into illusions and darkness and everything. So for now, let's just say physics is awesome. So is magic. So is the world. Hope you have a great day. We'll see you soon.